I said I had a movie, and so I showed it. And you show it by running step by step through, showing here's the text, here if you want to, you move the cursor over, and here's how you move the cursor, and then you can click on the word, and then bingo, you can have it disappear, or you can move it someplace, just bing, bing, etc. And so you actually reframe some paragraphs step by step, then you go back to the beginning, and you run it real time. And it hit everybody I showed any place just abruptly that whenever they'd been thinking about interactive computing, they'd never thought about just how quickly and flexibly you could do things.
And so what could the left hand do? And he figured out with 5 fingers, if you counted in binary, you could get up to 31. And so he thought, well, you know, maybe we could use a code like that. So he came home, I think I was 7 years old at the time, and he taught us this story about how if you know, whatever, you could use your finger, and it was a secret code you could spell things out. So you and your friends could have the secret code. So we learned this really fast, and our friends learned it really fast.
There are many, many things shown in that presentation that I wish people would go through and just sort of tabulate to say how many of those are things that fit into today's general pattern of work. And I think there'd be quite a few that you'd have trouble doing. The different viewing and the flexible jumping inside the documents. Because you say jump to link and click, the system will go searching downstream on that text to find a link. So some of the views you could say I only want to see 2 or 3 lines of a paragraph in there. So you could fix it so you're looking at 3 lines and the carriage returns have put the link underneath it. So could just jump on the bottom line, say jump link, click on the bottom line. So that's the way I could move around between a lot of the views. And so I think we sort of showed people what links were like, in different cases used them. And there's one in which I just had a graphic thing that I just evolved through to show them the kind of ways conceptually that this sort of provided knowledge for people. And no one's ever asked me about all that, and I would really like to find an opportunity to tag all those things and outline the kind of capabilities that were represented.
The disk image kfest2025.hdv is where you mount it into FujiNet, and it boots into this menu. And we're going to configure this machine as a server. Okay, the IP address can be changed here, and the port can be changed here. And if it's an Apple IIc Plus, it needs to know that. And now we are waiting for a connection. Okay, this Apple IIc is going to run the FujiNet client. And it has to connect to the server. So it needs to know the IP address and port of the server and whether you are running a IIc Plus. And now we make sure that the NLS server is running, which it is, and now we connect. And it sends and receives communication, and then we have to save the configuration file here. And then we can go to the server and save the configuration file there. If you don't have a FujiNet, you can still read several documents that were saved from the Hyperscope project, for example. If you go to number 14, you will be looking at Augmenting Human Intellect, Doug Engelbart's paper from 1962. NLS documents are structured into statements. So here's an example of a statement with 6 lines, and the lines have been broken at 64 character using some intelligent parsing. But each statement has metadata. So it's a level which corresponds to the outline level. So 1A and 1B here are level 3, number 2 is level 2, then 2A, and 2A1 is level 4. And then each node has a specific ID number, and the author of each statement is tracked. So CE is Christina Engelbart, and she worked on this April 24th, 1996 at 4:48 Greenwich Mean Time. So you have full provenance preserved for each statement of the document, and that enables addressability to specific paragraphs from anywhere else in the system. That's the FujiNet. So this is the communication infrastructure that simulates the NLS system, and that is the hardware simulating a chord key set and the mouse buttons with a 2GS keyboard and mouse. But the communications is all done over FujiNet. Say we wanted to send a dragon, we say 1D, and we have a tic-tac-toe dragon. And say we want to send an O to box 2, we say box 2, O. And on FujiNet, we can see the O on that monitor. Now let's look a little further at how we test this hardware, which is really just 8 buttons interfaced to paddle 2 and paddle 3. So this program called PaddleGraph is a high-res display of the paddles, and there is a short delay loop between reading paddle 2 and paddle 3 in order to avoid crosstalk between the paddles. So let's run this, and you can see at the bottom the 2 values, and the top half of the screen is what's currently pressed. So now let's press the thumb button on the left hand, and that's a 0. Okay, that's the number 1. Now let's go to a 2. With these 4 buttons, these are one paddle, and the other 3 are the other panel. So looking at the leftmost 4 buttons, this is a 1, this is a 2, a 3, a 4, a 5, 6, 7, and then the pinky is an 8, then a 9, 10, 11, 12, 13, 14, and 15 is all the way at the end. So that's digital to analog conversion. And the same thing applies to the rightmost buttons.
One of the interesting things that NLS does, just an advantage of being online, is it keeps track of who you are and what you're doing all the time. So on these statements, on every statement that you write, it keeps track of who you are and when you did it. So not only can people leave notes around for each other, but sort of automate it into how there's an automated aid here that tells us who did it and when they did it. This picture in our system guide file is a picture of the overlay structure. Let's go look at move word construct. I just select this link, and here is the file. This file is written in one of these many special languages that we've designed. This language has helped us write the kind of fast, tight code that we want, that we have to have to operate in a time-sharing system, and at the same time, it's given us a lot of flexibility. It's also the phrase structure of the MOL. It's designed to sort of mesh with the block structure of NLS. So here I've got a while statement. To see what's in that while statement, I can move down and see its 3 statements, which is an if statement. The if statement is a single if statement, which has an if and an else part. And that whole block opens up to all of that. So by using the MOL like this, I'm able to move around very quickly in my MOL files. Also able to sort of zoom in and out of things. By having all of our compilers written in a higher level language themselves, we've been able to change them all the time. So we're not only able to quickly modify the syntax of the control language for NLS itself, or the meanings of the commands by working in our high level language, but we're also able to go in and just change the compilers as quickly as we have to accommodate all sorts of new hardware features and experimenting that we do like that.
I'd like to be able to move around very flexibly, and then I'd like also, whenever I get someplace, to be able to, if there are various views that help me get the picture what's supposed to be being contained in that knowledge, help it portray it for me.
What are the different views?
All the different levels in there, and I'm showing you the way the location of them is described with alternate, like 4A1 means it's under the fourth main branch, and 4A means the first of the subordinate branches there, and then 4A1, 2, and 3 are the subordinates of that. But these are things that, like this could be a chapter, and these are sections, and these are the paragraphs in the section. But it just lets you go arbitrarily deep, but keep track of it. And so if you might notice that every paragraph, or it's in there, there's only one line of it.
Yeah.
And that's because I've chosen, when I construct this view very quickly, I didn't construct it, I said, show me this view, and the computer constructed it. Then I said, I just want to see the first line of every paragraph just to help me understand what might be any place. And for instance, I could say, oh, I'm interested in this down here at 4B. One of the underlying concepts is, say, for completeness, I found something here. Well, let me jump to that. Oh, that's another view that, in my own hunting around and studying it, shows me something I wanted to make clear to myself. Well, then show it to me all wide, everything, so I can read it again.
Yep.
So these are the kind of flexibility. And another thing is, you'd like everything to be addressable, if you wish. So I could say, I want to jump. I want to jump to the item that's 7B. See, I labeled that there. This is down here. Well, it'll jump me to that then, see? It'll really show me that. And I see, oh, I have a link. That's what defines a link. It's an address, which can be much more sophisticated than that, pointing to anything in any of my files. And then on every time you have a link, you can specify that when I get there, this is the explicit view I want.
Yeah.
So let's just say, what if I say jump to link, and then select that link, and then say go. See, bingo. Just the particular view I wanted to see. What if I pick this statement here? I'll say I'm going to replace this statement with this one.
Yeah.
So bingo, it's there. And so then I can look at something like, I could say, oh, you know, this language and methodology ought to be interchanged. Well, there's a verb called transpose that says interchange. Well, I want to transpose two of these statements, see? Bingo. I could transpose two chapters, sort of beacon this thing. Transpose branches. That's, well, yeah, transpose this whole branch with this one here. Bingo. And everything under it went with it. I can hit a question mark anytime, and that'll show me all the verbs. It only takes one or two letters to specify what you want, and then it comes out here full. Like pick a verb.
Jump.
Jump. So you see, it's just lone K. So I just hit G, and it says I'm going to jump. And then it says to where?
To.
Then I can hit a question mark if I want to. But these are all of the things that we ended up getting as specialized targets. That's where you want to jump to.
Okay, so for instance, word.
Jump to work, huh? Okay, then you have, what's this question mark, options, the first or the next. So I could say jump to the word first, assume. I can click on it there. Jump to the first. Oh, there's an assume. See? Is there a next one? Yeah, there's an assume. Oh, is there another one? Yes. Oh boy. Oh, look, a lot of assumes. Huh?
How, for instance, do you go to your email
Uh-huh.
and your address book? How do you navigate?
Well, I usually could jump. If I say my address book, I call PH for phone, see? And I could just say, I want to jump to PH, and I put a comma behind it, which that says it's expecting to find a file named PH. And I can go there. But if I want to, I can also say, I fixed it so the last names of everybody in there was actually the label of that paragraph.
Okay, so you go, for instance, to Hagland.
All right. See, that's what's in there like that. So then I'll go and I'll say, it gives me a chance of review. So I'll say, okay, just look at what's Hagland and anything that's below it. See, there I am. Here's a message from Frode that says it's something like here. Talking about the documentary, that was 25 November last year. Well, let's jump to that link on that. There was just a note under his thing. Bingo, there I am with, that's the email that Frode sent last November. But let's jump to the head of this and see what all kinds of categories are there.
Oh, wow.
There are all the categories, and I can look down any one category.
Yeah.
See? Or I know that I've done it so that I said, after a while I stop showing categories and then just start showing files.
Yeah, because this is files and emails and
Well, it's
notes. To say notes or whatever.
yeah. See, under each one of these would be a set of emails, something like that. See, your emails talking about hyperscope, so I stuck them all under something called, I just abbreviated as HS. But it was years and years of evolution with these basic concepts of let's keep evolving, finding more functions, adding them. If they prove to be useful, add them, refine them, do this and that, change the conventions. And so that was still evolving in the middle 80s from the middle 60s, so that was 20 years evolving. But the very early ones were made with this basic idea of could address anything and could provide views and jumping and linking. This gives me the view of the master set of files, see?
Yes.
And I can go down under each one just like it's a primary folder, see? I go say what's under that OHS one, it'll show me what's under there.
Yeah.
If there are more layers down there or not. So this was acting like a folder. Boom. So each of these is something I can link to right away. Whichever one I wanted. So the sort of link to it and then the name of it afterwards. Well, this I'm looking for a section here where these are kind of mail storage files down here. And
That's very sexist.
and so I can pick any one I want to and go open it up. I want to jump to item, and I know it's got a number, 80360. It's a numbered file. So I say, okay, I want to go there, and I say, all right. So then it says what view I want, and you asked for what view was it?
First sentence only of each paragraph.
Okay, the top level.
Yes.
How many lines do you want blank space between them or
Yeah,
not?
blank space is nice.
Blank space between them. Okay, do you want them numbered or not?
Yeah, number.
Want them numbered, all right. So I think we're ready to go. So
Okay.
we just say, all right, go. Other systems of today's settings are something you often go off and change, and then every place you move after that, those settings prevail. And in Augment, we have a lot of different kinds of settings that you can just do on the fly. Because at that time it'd be more convenient if the setting were like this rather than like this. I'd like to include in this particular view that plex that thing's pointing to.
Yeah.
And it's pointing actually to the file I want to go. So all I have to do then is hit this other view spec, and it includes that, it includes in this view that thing that you're pointing to. So you don't have to actually people don't have to actually go there. They can just have a picture of it included if they wish, and they have their choice as they're coming through whether it's going to include or not, or just tell you the name of what's there.
This Apple IIe with a mouse is running WeGUI Fuji NLS, which is just a standalone test prototype showing a document created December 3rd, 1968 by Doug Engelbart. And this is just the demo that he used in his December 8th, 1968, showing his trip to the market and what he would have to do on his way home from work. Now, if I press the X, that is changing to a view spec of one line, of only one level and one line. And now, if I press the B key, that is another view spec that increases the number of levels displayed. So level 1, level 2 is the market, then he has to go to the shoe store, the hardware store, the art supply, the drug store, and then I'm using the down arrow and up arrow to scroll, because then he has to go to the library, and he has 2 overdue books. So now if I type a B under Indians, there is text. And remember, this is from 1968. We would say Native Americans today. So you could have multiple lines of text, and that's what this number would be. Now, if I press M, it is going to display statement numbers. And here you can see that this first number is a level, and then the statement numbers are assigned, and they are permanent numbers. There is something called purple numbers, which would be like 1A, 1B, 1C, but for now I'm just displaying this. Okay, now for this statement 138, there it is multiple lines, so there's a view spec if I only want to display the first line of that statement, or if I want to display all the lines. So this is the third line of the statement. Let's collapse again. If you want to see blank lines, you press Y, and the view spec Y puts a blank line, or Z removes the blank lines. The letter N removes the numbering. And you can use the mouse to scroll and to quit. So let's explore the Git repository for this project. What we're going to look at are these OPML source files from Hyperscope 2006. And one of them uses AI-generated code. Well, there are several Python scripts that were generated by Claude. For one of the generated codes, I stored each version that was generated by Claude, and this gives you the prompts of the text that generated each of these Python scripts. And then this version 2 is the one that I used to do the joining of the CSV files. So the purpose of this scripting was to create a shell script that would pre-process each of the OPML files that was saved from the 2006 Hyperscope project. For example, here is one of them, and this has all the structure information, so you could see what Doug did and what Christine did, and when they did it in 1990, and then the node IDs and the text of each statement, all preserved in the OPML from the original augment document from 1991. Okay, so given that OPML file, each of these, it starts with an opml.tocsv.shell script, which is here, and that runs 3 shell scripts, one creates the index, one creates the lines, and one joins the two index and line CSV files into a join file. So you're going to see index, lines, and join. And all the output goes to this text file. So there's a README in here that shows the command line. So this runs this shell script and outputs all the output of the programs to a text file and what each of these CSV files are. So the goal is to create CSV files that can be used to generate data statements for AppleSoft in an efficient way. As an example, looking at tutor join, let's look at tutor join. So this CSV file, it has the structure line, and then it has a match count, which is here, this number 7 is the count of the 7 lines of text, and it's broken at words of, so each line is less than 64 characters. So that an AppleSoft version can say, okay, give me only the first line of every statement, and then it would just pull all these statement number 1s and render it on the 80 column screen. So to make all that happen, there's 3 shell scripts. So test index runs a Python script in a virtual environment. So OPML to CSV index. And where is it? Here it is. Okay, so this is code generated by Claude AI, and it's just magic, right? Okay, and then this one creates the lines. So it figures out the line number. It does the breakup of the 64 characters per line at word boundaries. More magic. And then the third one is the join. So test join.sh runs csv join script.py, csv join script.py, which joins the 2 CSV files and creates the output file and more magic. But okay, so here is the output of all OPML. So for each of these OPML files, you can see its progress, but for certain files like augmenting human intellect, it found some mismatched keys that don't have structure elements in the index file. So I'm not worried about this. This can be further research, but we have enough test data to play with.
People weren't understanding what I was saying, or if they did understand them, they would feel like it's so outlandish that they'd have a hard time believing that any sane young man or sane old man would be adhering to them. It really made it very hard to approach people when I was first at SRI, or for that matter, for decades, to write proposals for what one would want to do.
The GitHub for this project is at github.com erangel kfest 2025, and the issues show the work that is in progress for this project. This gives an overview of the project, its goals and objectives, and some background information. And then the other issues describe specific tasks like the GS mouse driver and key set paddle logic, and the idea of using a DNS file, which would have nodes that mimic the early internet when there were only 3 or 4 nodes on the net. SRI, UC Santa Barbara, and the University of Utah. There was an attempt to do some AI generation of code, which for Apple, AI is not the best, but it was tried. Thank you.